Good afternoon, everyone. This is Asma Namdar Qazi from ENDC Department, Trinity Academy of Engineering College. So we'll start with next unit of EC, that is electronic circuits. The name of this unit is voltage regulator. In this unit, we'll see the need of these voltage regulators along with the different ICs available as a voltage regulator. So first I will share the screen here. Now in this voltage regulator, first we'll see what is the voltage regulator. Here, it is a circuit which is used in between the filter and a load. That is, the requirement at the load side is that the constant voltage must be supplied to the load side. But due to changes in the temperature or changes in the at the input side, that is at the supply voltage, or due to the changes at the output side, that is the changes in the load. So this voltage can be have a varying values. So that's why the requirement of our circuit or any kind of circuit is that the supply of the voltage to the load side must be a constant value. So here, that's why this voltage regulator is used at the supply side, at the input side. So we'll see the voltage regulator IC. First, we'll start with IC 317. Here, you can see that the basic building blocks of these ICs is, it contains first reference voltage, then this reference voltage is sampled with the current voltage. Now there are these two inputs, that is first is reference voltage and second is sampled voltage. Now there must be a comparator which will compare these two signals, and at the output side there is a controlling element, so which will control the voltage to a constant regulator value. So here, this is the typical application of this voltage regulator. You can see that this IC 317 is a positive voltage regulator. The specification of this IC is, it can provide a wide voltage range. That wide voltage range contains the voltage from a value 1.25, that means so less value, to the higher values like 37 voltage. That means this voltage regulator IC can provide a wide range of output voltages. That means as per your requirement, you can use or set the output voltage according to the according to your requirement. Okay, and along with this, the current here supplied by this regulator is 1.5 ampere. That means sufficient amount of current is also provided by this. If you are designing some circuit, so you can use this if your specifications are matching with this voltage regulator. Along with this regulator can provide a short circuit protection. Along with it can provide a thermal variation also. That means the changes at the due to the temperature won't affect this voltage regulator. Okay. Now here you can see that only two different resistors, that is R1 and R2, are used to set this voltage regulator to a particular value. Here, among these two voltages, resistance, R1 is a fixed resistance you can use, and R2 is a variable resistor. That means you can change the values of this R2 resistor as per requirement of your circuit. Now, this was a positive voltage regulator. That means the output was a positive voltage. Now, if you are designing some voltages, some circuits where the requirement of your circuit is to have a constant negative voltage. So for that, to fulfill that requirement, next IC is IC 337. It is a negative voltage regulator. Okay. Now, the main specification of these two voltage regulators is that it is the adjustable voltage regulator. So this adjustment is provided due to this R2, that is a variable resistors. Here you can see the specifications of this second voltage regulator, that is a negative voltage regulator. Here you can see that the output voltage range is a negative voltage. In 317, it was a positive voltage range. Of course, it was the same 1.25 to 37. Here, it is a negative voltage range, that is minus 1.2 to 37 volt. Again, the maximum load current is near about same to 317. Here it is 300 milliamps to 2 ampere. It is dependent on the different package type. Now, these are the typical line and load regulations. Those are also very good. If you can see, if you can compare with the other regulators. Now, this is how these two regulators, 317 and 337 will look. Here you can see it is a 3-pin ICs. 3 different pins are there. First one is adjustable, that is the adjustment you can provide. Second is input and output. Now this is how various applications based on these two ICs. Here you can see that the internal interference voltage appears across R1 and R2. Here, along with resistance, some capacitors are also used. Now, next is load dropout regulators. Now, in 317 and 337, the input and output is having a different values. So, if your input and output is having near about values, so at that time, 317 and 337 won't be able to work. So for that, a new type of regulator, that is low dropout voltage regulators, are used. Here, the input and output values are having a what we can say are a comparable values. Those are not having a large difference. So in such a case, you can use low dropout voltage regulators. Here, the LDOs, that is low dropout voltage regulator, those are depends on the supply voltage range, load voltage, what you are using. Along with this, the maximum dropout voltage required for your circuit. Now, up till now, we have seen that there are some linear type of regulators. There are some LDOs, that is low dropout linear regulators. And along with this, there are some switch mode power supply also. Those are called as SMPS. Here, you can see that first, here it is PMOS LDOs, that is low dropout voltage regulators. Again, this LDOs is having same type of blocks. Just we have discussed for 317 also. Here you can see the voltage reference, that is the reference voltage is there, and that reference voltage is compared with the output voltage, which is sampled through R1 and R2. This is the voltage divided by circuit. So these two signals are given to the amplifier. So this is the error amplifier, which will, what we can say that, compare these two signals. First one, that is the sample signal along with the reference signal. So he will produce the different signal, and along with this amplifier will amplify the signal also. Now that is given to the controlling element. And again, that is given to the output side. This is how LDOs are working. Now we'll see what is the switched mode power supply. So here in switched mode power supply, here active switches are used. Now, which are the active switches? Transistors, SCRs. These are the some types of active switches used at the in the voltage regulator. So these SMPS transfers power from DC to AC source or to the DC loads. Now this is the block diagram of SMPS. Here also you can see that the main element in this is PWM. PWM is pulse width modulation. Here this circuit produces a kind of output which is used to turn on and turn off this high frequency switch. Here you can see the duty cycle is controlled by this control circuitry, and that output is given to high frequency switch. This switch turns on or off according to the output of this PWM. Here, this switch is, you can see that it is a FET, or else you can use transistors or SCRs also. That means the input power supply is first given to the rectification circuit. The output of that rectification circuitry is given to the this frequency, high frequency switch, which is turned on or off according to the PWM. Now next, that output is given to the power transformer, and again the rectification and filtering of the same signal is done, and it is given to the your output circuit. So here, these are the some main points of this AC to DC SMPS. Just now we have discussed. Here it uses the input rectifier and filters. Along with this, it has some switching devices, active switching devices. Next to that is transformer and output rectifiers. Along with this, it uses feedback and control. Again, as per your requirement, the feedback is given to the input side, and the required output is produced at the output side. Now there are some different types of this SMPS. These are very, very simple types. You can see that there are two different types of AC or DC power supplies. So here the different types are AC to DC, DC to AC. That means converting from AC to DC or DC to AC, again from AC to AC or DC to DC. Very simple to understand and very simple to keep in mind. Now these are the some advantages of this SMPS. It has very high efficiency of 68 to 90%, which is a good efficient circuitry if you are using this SMPS. Along with this, it can give a regulated and reliable output regardless of the variations at the input supply voltage. So this is the main motto of using the voltage regulator, that your output voltage must be regulated. That means there should not be any kind of major changes at the output side voltage. So this criteria is fulfilled with this. Along with this, it is smaller in size and lighter in weight also, and it can provide high power density, and the technology is quite flexible also. Along with these advantages, there are some disadvantages also, because as it has an active switching element, there can be a noise due to this switching. That means when that device is turning on to off or off to on, it will produce certain kind of noise. So it will generate noise to the total circuitry or total environment. Along with this, some kind of complexity is there in this circuitry, and it will produce also electromagnetic interference also. But still it is used in different or various kind of applications. First, we have seen that it is used at our home computers or all the type of computers. SMPS is used. Before 5 years, each and every computer is having SMPS, because at that time, the supply voltages or the electricity is having quite cutoffs, but nowadays that problem is solved near about most of the time. But still at home computers, you can see that SMPS is installed, definitely. Along with this, it is used with electronic circuits, which is very sensitive. That means those who wants a constant power supply, the SMPS is used. Some battery operated devices and some devices which requires high efficiency. So all these are some kind of applications or uses of this SMPS. So this all was covered in today's session. We have seen first what is voltage regulator, requirement of the voltage regulator. After that, we have studied two different ICs, IC 317 and IC 337. 317 was a positive voltage regulator and 337 was negative voltage regulator. After that, we have studied LDOs, that is low dropout voltage regulators. And lastly, we have seen what is SMPS. Okay, so that's all today for today. So we'll stop here. Thank you, everyone.